Click Calculus. Let's go down to Continuity and click on 17 here. What do we got? We got this piecewise defined function. We want to find the limit as x approaches 9 coming in from the right hand side of f of x. Let's move over to the whiteboard. So we have f of x is equal to, we have x squared, and x does not equal 9. And we have a constant 3, and x is equal to 9. And we want to find the limit as x approaches 9 from the right hand side of f of x. Right hand side of f of x. And what I'm going to start off with is we're just going to sketch out the graph here so you can kind of see what that looks like. So 9 is where we're concerned at. And let's look at this one here. What is, if f of x is equal to 3, okay, that would be this part here, where the only number in the domain is 9, right? So in other words, f of 9 is going to be 3. So we'll put a solid dot right here. So that's it. That's the graph of this guy right here where this is the domain. Now what about this one? Now this is not going to be to scale here, so okay. If 9 squared, this would be 81, of course. Now the graph of this guy is going to come up, do something like this. Okay, this is not a very good picture of a parabola, but I'm trying to sketch this out by hand on something very slick piece of plastic here. Alright, so this line right here is the graph of the top part, and of course this point right here is the graph of the bottom part of this piecewise function. Okay, now they're asking for this, but moreover we can actually answer this question too. And we would just use the top part because we don't care. They can throw 9 out. We can have a missing point. Right? That's what the limit's all about, is we can find where that missing point is actually at. Now what does this mean right here? This means that we're coming in from this side and this side, both sides, left and the right. And so we end up using this top one up here. I'm just going to write the limit as x approaches 9 of x squared. We just do direct substitution and you get 81 out. Now this right here says, okay, coming in from the left it's 81, and coming in from the right hand side it's 81, and this is coming in from the right hand side, so it's 81. Okay, as you can clearly we can clearly see. Alright, now let's talk about continuity quickly here. Continuity, first thing we need to test is f of 9, does that exist? And f of 9 does exist. Actually it's 3, right? F of 9 is 3. Okay, now what about the limit? That was this guy right here. The limit of f of x as x approaches 9, what is it equal to? Well, it's equal to 81. And then of course the last condition, so far the limit exists and f of 9 exists, but the next part of those conditions is that both these numbers right here must be equal, and they're not equal, therefore it's not continuous at 9. This function is continuous everywhere on the real number line except when x is equal to 9, so this is not a continuous function. Alright, so those were the three, remember the three conditions. Okay. Good enough. Let's hit the answer here. Forgot 81, right. That's what we were looking for right there. Okay. So come on by, practice, and I'll see you there. Bye.